We're doing vector word problems here. Leaving the outpost, Alejandro went on a 3-day journey to the desert. His displacement, distance, and direction from start to finish on day 1 was this vector right here. His displacement from start to finish on day 2 was this vector right here. His displacement on day 3 was D3. Okay. Took him back to the outpost, so he went back to the beginning. All right. The distances are given in kilometers. What distance did Alejandro travel on day 3? Okay. And what direction did Alejandro travel on day 3? Assume 0 is in the rightward direction. Okay, so they're just saying that it has the normal direction of 0 going to the right. Okay. Round to the nearest degree, your answer should be between 0 and 360 degrees. Okay, and they gave us a little picture down here so we can kind of see what's going on. Yes, and then our final one is going to be where he goes back, all the way back to the start. And so usually this would kind of be facing the other direction. So if we added it, then we would just go ahead and if we added these two vectors together, so I'm going to go ahead and find D1 vector plus D2 vector. Okay, and then that would give me where it's a terminal point at the end here, but I want it to go all the way back to the initial. So in what direction did Alejandro travel on day 3? He went back to the beginning, straight back. So that's going to be kind of like a negative. So whatever that answer is for D3 here, whatever that vector answer is, I want to go ahead and apply the negative to it. I want to switch directions on it. So I'm going to switch directions at the end. Which is what they want. In what direction did Alejandro travel on day 3? Okay, so let's go ahead and give our best shot at this. And let's see. Okay, so whenever you're adding vectors, which is what we have to do here, we'll go ahead and add up the x components, we'll add up the y components, and then that'll kind of give us the last one here. Okay. So let's see. D1 is equal to 3i, where I is a unit vector for the change in x, plus 7j, same thing, unit vector for change. So I'll go ahead and just put those are change in x's right there. These are change in y's right here. And D2 vector, go ahead and put it right underneath it, is equal to negative 1i and plus 8j. Okay. All right. So we'll just go ahead and add those together. Luckily, it's already kind of in component form here, so we're just adding straight down. And I get, for my D3, that's where I've added them together, is going to be equal to 3 minus 1 is 2. And that's the components for I. And plus 15, those are our components for j. Okay, so what distance did Alejandro travel on day 3? So if we're going to find the distance here, we're going to use this new vector right here on day 3, the distance he traveled. So that's just going to be looking at the distance formula for these components. So I'll go ahead and do that over here. So the distance is equal to the square root of the x components, which in this case is 2 squared, plus the y components, which is 15 squared. So this is going to be equal to the square root of 4 plus 15 times 15 is 225. And that's going to be equal to the square root of 229. And they want it to the nearest tenth. So the square root of 229. Square root of 229 is equal to, as a decimal, this is 15.132. All right, dot, dot, dot. This goes on forever, which is approximately equal to, and we want tenths place, 15.1. All right, so we got that answer right there, 15.1. That should be the distance that he traveled. And then next is I want the direction that Alejandro traveled on day 3. So the direction, I'm going to go ahead and do the normal direction, which is just adding it. Then I'll switch directions just by adding 180 degrees. Okay, so the direction here is going to be the angle that these kind of make. So I want to build a triangle here so I can do find the angle of that direction. Okay, so the triangle is change in x. So an x change on the triangle is 2. And a y change on the triangle is nice and big as a 15. And then I'm looking at what that direction is. Okay, and that kind of links together with what I have here. If I started at the bottom and I went all the way up, that's like a small change in y and a big change in x. And I just want to kind of show that. So here's a 2, 1, 2 for the change in x. And then 1, 2, 3, 4, 5, 6, 7. And it's probably 15 up. So that's definitely kind of how they're doing it right there. All right, so I'm looking for this change. I'll call this theta. That's what we need. And this is our adjacent side, adjacent. This is our opposite side right here. All right, and that's our tangent. So let's go ahead and do tangent of theta is equal to opposite over adjacent, 15 over 2. Arctan on both sides, so theta is equal to tan inverse 15 over 2, which equals calculator, and we are in terms of, what do we got? I'm going to go ahead and just do it. Oh, degrees. There it is right there. So notice that little degree sign, and there it is between 0 and 360. Okay, degrees. All right, so we're in degree mode. Check on my calculator. And I'll go ahead and arctan, shift tangent, arctan of 15 divided by 2. All right, I got 82 degrees. All right, so that's 82.405 dot, 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 and we're in terms of degrees here. All right, so that would have been the 84 degrees is going up this way. So that's the 84 degrees. But we need to be careful. He went back down to the beginning. He took him back to the original spot. So what we're going to do is we're going to add 180 degrees, and 180 degrees will change the direction here. So we're going to go ahead and switch the direction on this by adding 180 degrees. So 84 plus 180, and that's a dot, dot, dot. Remember? So this number right here, it's still on my calculator. I'm going to go ahead and add 180 degrees to flip my direction, and then that should link everything together. So that final answer is plus 180 equals 264.405, and they went to the nearest nearest degree on this one. So careful, that one was nearest tenths. This one's nearest degree. So that's just going to be approximately equal to 264. All right. That should be everything that we need. Let's check to see how we did. So I got 15.1 for the distance he traveled. And the direction that he went going back home was 264, rounded. Got it. So all of these are kind of similar in their dynamic and how we solve them. You just have to be careful that you make sense about what they're actually asking.